this webcast continues discussing the lab on conservation of momentum. We are in part 1 and at step which deals with explosive impulses, and we're at step 20. So we just finished writing a physics equation for this activity, and then we cross-multiplied to find this relationship that says that the momentum of the red cart equals the negative of the momentum of the blue cart. The reason that we could end up with zero momentum in the system after the explosion is because the two carts moved in opposite directions and therefore their momentums had different signs. Okay, so now I'm at step 20, which asks us, was momentum conserved? Well, looking back at the table, I think we have to say yes, because we had a final momentum of 0 for every explosion that we performed. And we know that the initial momentum was 0 because the carts were not moving when we first looked at them. Okay, so yes, momentum is conserved, and let's say that. Momentum is conserved during the explosion. The initial pre-explosion momentum of the system was 0 because neither of the carts was moving at the beginning. Okay, both of their velocities were 0, and so their momentas were 0. Okay, the final post-explosion momentum of the system was also 0. The two carts moved in opposite directions so that their individual momenta had opposite signs. The sum of the momenta from the two carts always added to 0. Okay, so yes, we did have a situation where momentum was conserved. Where did this momentum come from? So each cart had a spring-loaded plunger. Which could apply a force on the other cart. Equal forces acted on both carts for equal amounts of time. Therefore, each cart experienced the same magnitude of impulse, and that impulse resulted in the same magnitude change in each cart's momentum. So again, the signs of the two momentum changes were different from each other, but the magnitudes were the same. Okay. And then in step 22, it says, demonstrate that the units for impulse are the same as the units for momentum. Because, we've been saying that the impulse equals the change in momentum. So let's just be clear that they do have the same units. So for impulse, that equals the average force multiplied by the elapsed time that the force is applied. So the units of impulse would be the unit of force, which is a Newton, multiplied by the standard unit of time, which is a second. Let's simplify that a little bit. A Newton is a kilogram multiplied by meter per second squared. And of course we've got the second. One of those seconds can cancel, and we're left with the units of impulse being kilogram meter per second. Okay? And then the momentum equals the mass times the velocity. So the units of momentum would be the unit of mass, which is kilogram, times the unit of velocity, which is meter per second. Oh, well, that's just kilogram meter per second. So they are the same, the units of impulse and the units of momentum. Okay.